Hello everyone. In this video, we can see the introduction to the Internet of Things. So here there are two important words to be discussed. One is Internet and another one is things. So Internet and things, basically the concept of Internet of Things is a combination of these two words which makes wonder. So let's start looking into the concept of internet. Let's see what is meant by internet. We know internet very well. Internet is the network of networks. So what is a network? Network is an interconnection of two or more than two computers. As of our knowledge, see, for all these days we were all discussing about the network as the connection between two or more than two computers or any other devices which are associated with a computer. So we know the basic idea behind networking. The idea behind networking is to share the information, at the same time to share the resources also, at the same time to exchange the information from one machine to another machine. That is what is meant by sharing. Resources means I can connect a single printer which could be shared among the different computers connected in a network. So when I start thinking of such as very small networks, normally we call it a local area network. If I connect them together, it is going to be a metropolitan area network or a MAN. For example, if I connect such small networks which are spread over Udupi district, I could think of a metropolitan area network, a complicated network which is connecting these two networks, these networks. But when I start thinking this concept of networking at a large scale, which could cover the entire network spread over the globe, then I can say it is internet. We know internet is nothing but internet working. Internet working. So when we think of the concept of internet at a broader way, at a broader range, we always think of computer, computer associated devices, some resources. Yeah, now we could expand our thoughts to tab, to a smartphone. Basically, all these are the different types of computers. So this is something related to internet. Now let's talk about things. What do you mean by things? A door lock, it's one thing. A fan which is rotating and which is giving a cool breeze, it's a thing. An AC, it's a thing. You think of anything that could be an example for a thing. Your vehicle, it's an automobile thing. An electric stove for used in kitchen, it's a thing. TV, it's a thing. So refrigerator, it's a thing. So anything and everything are things. Anything and everything. All these are things. Now a solid logic is built up. Here, so far these are all things which were manually handled by people. I can close the door, I can lock the door, I can open the door, I can switch on the fan, I can switch off the fan, I can use my refrigerator, I can take my vehicle and I can go. These are all manual things. But when I think of connecting an internet to these things, a wonderful outcome is expected. And it is visualized also. It was expected earlier, now it is visualized also. So, the concept of Internet of Thing is defined as a dynamic global network infrastructure with self-configuring capabilities based on the standard and interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities and use intelligent interfaces. And these are seamlessly integrated into the information network, often communicate data associated with users and their environments. A beautiful definition for IoT is given. It is defined as a dynamic global network infrastructure. It's a global infrastructure, global network infrastructure. I cannot restrict myself into a small network which I have in my lab. I cannot think of IoT limited to my lab because its infrastructure is spread globally. It is dynamic, means it keeps on changing. Applications are dynamic. I cannot limit myself to a static application. I want a live application. I could get a live application. I'll take an example. When you are crossing the toll gate, dynamically your FASTag is deducting the toll fee from its account. How is it possible? Because the FASTag connected to your car is satisfying a dynamic global network infrastructure with the self-configuring capabilities. There is no static configuration possible. Yeah, we have studied the different versions of IP version v4, IP version v6. So when we look into the comparison, when we compare these two, IP version v4 with IP version v6, one of the greatest facilities we get from IP version v6 is it is having self-configuring capability. It is the need of the day. I don't want to statically configure my system. When I was talking about the IP version v4, I was totally restricted. How I was statically configuring my system, my computer, my laptop to the internet, and I cannot shift that to different place because The configuration is limited to that particular place. But the moment IPv6 has come, it is providing a facility for automatic configuration, due to which today we are all enjoying seamless internet facilities in our smartphones, because smartphone keep on changing the towers as we move from place to place, but the services, but the operations, but the connectivity to internet is not breaking. It's an unbroken facility we are getting through these smartphones. Why? Because it is having a capability of self configuration. So, therefore, IoT is having another characteristic, that is, it is capable of self configuring based on the standard and interoperable communication protocols. So, it's very important to have interoperable communication protocol for communication, where a physical and virtual things. Earlier we were having, yes, IP version V4 as well as IP version V6, limited to a communicating devices like laptop, desktop, smartphones, tab. Basically, these are all the different modes of computers for communication. So, overall, I can say the IPv6 was is or IPv6 is giving facility for auto configuration, self configuration, and interoperable communication protocols, where computers were able to communicate with the different computers which are spread globally. But today it's even possible for physical and virtual things. I'm talking about things. Your door lock can communicate, your fans can communicate, your vehicles can communicate. Because of this auto configuration or self configuration capability, because of the interoperable communication protocols, so today even things, physical things or even virtual things also can communicate, and people can control these devices as per their requirements. And these things have identities. If at all I make my door lock configured to this IoT, if I make my fan configured to this IoT, if I make my TV, if I make my refrigerator, if I configure my automobile vehicle, either it is a two-wheeler or a four-wheeler, which could communicate using internet connectivity, then these things also have their identities. Unlike your web servers. Basically, we say web servers have their identities. We locate them by giving their URLs, by giving their domain names. But here, the virtual things, even physical things, also have their identities, also have their physical attributes, and also have their virtual personalities. So, because of these things, they can be treated as intelligent interfaces. See, our physical things, what we call the door lock, fan. These by themselves cannot be using communication protocol. They cannot be used for communication. We cannot control those devices, but we give them a proper meaning by using an intelligent interface. So, these physical things and these virtual things have their identities, have their physical attributes, and have their personalities by using the intelligent interfaces. So, the concept of IoT is not just limited to the device, it is extended to a device along with the intelligent interface which make the thing as internet of thing. Earlier it was just a thing. Door lock was just a thing. Suppose if I use an intelligent interface to the door lock, then my door lock becomes internet of things, IoT. That's a concept which we are learning. So, with the help of the intelligent interfaces, these things are seamlessly integrated into an information network. So, the physical devices which are seamlessly integrated to the information network by means of usage of intelligent interfaces, and they can communicate the data associated with the users and their environment. These devices, with the help of the intelligent interfaces, can communicate data associated with the users and their environment. For example, the last sentence I'm going to give an example. Suppose if I feel that I have a smart device in my car, which I could claim it an IoT, and if I find that the car is moving without my knowledge, so the car keeps on sending data associated with it. So the car is sending the data to me. I will get a notification. I will get a details that where the car is moving, at what speed the car is moving, who is, I can identify who is actually driving it. Suppose if I feel that no, the car is getting stolen, I can send a command from my smartphone to stop the car. Car will stop and car will not move. How is this possible? It is possible due to the data communication which are associated with the device, which are getting communicated with the users and their environment. So IoT is defined in this fashion. So you need to mention the dynamic global infrastructure, auto configuration capabilities with using interoperable protocols. You need to mention the meaning of the thing, physical thing and virtual thing, how they use the intelligent interfaces, how are they sharing the data. These are the points which you need to know when you define the IoT. So the Internet of Things comprises things that have unique identities and are connected to the internet, because these things are globally identified, maybe by means of some credentials which you may know but your friend may not know. Let me give an example. Suppose when I buy a new car which has got IoT in it, the IoT is configured in one particular mobile which is registered to that particular car, so that it should be globally identified by only that particular app given in that particular mobile. So he can control the car globally. That's why The Internet of Thing is the one which is uniquely identified, which are connected when in the internet. That's one very important requirement. You cannot have a multiple Internet of Things with a unique identification, with a common identification. When you have multiple of things with a common identification connected over the internet, what are you going to control? Are you going to control your device or are you going to control other device? So basically, the Internet of Things comprises the things that have unique identities and are connected to the internet. So while many existing devices such as our computers or 4G enabled mobile phones, so they are all uniquely identified. We know it very well. So when we talk about Internet IPv4, we say Class A addressing scheme, wherein not only Class A addressing scheme, but all the classes of addresses. We normally mention that any computer connected to the internet should be uniquely identified. So the same concept is now extended to the thing also. So here the thing should be uniquely identified by the system. So of devices are things that are traditionally not associated with the internet. That's what I was meaning in the meaning definition. The things are traditionally not associated with the internet. It is the interface, what you design, what you plan, which makes the traditional device or traditional thing to be connected to the internet and is accessible around the globe. So, as I was mentioning, what are the devices you can think of? Thermostats, which you could control based on the temperature, the various utility meters, a Bluetooth connected headset, irrigation pumps, and sensors. Today, agricultural industry is working a lot in adopting AI technology, adopting IoT in the different agricultural activities, which may include irrigation, which may include soil culture, which may include the uh, disease analysis, disease control. So many activities are there which do require IoT devices in the agricultural sector. So control circuits of all the car engine. So today, if you buy a new car, all the cars, most of the business class cars are associated with an applications which you could download in your mobile phone. And using the mobile phone, you can configure the various activities of the car and you can get the details, various details of the car. And all these things are possible because of Internet of Things. See, to give an example, Maruti Suzuki has their app called Maruti Suzuki Connect, through which you can analyze how is your driving skill, what is the rate of your driving, what is your acceleration, what is your steering turn radius, what is your braking style, is it good, is it average, is it bad, all these details you get dynamically. So GPS provides you the help, it provides you the global positioning of your car. It also tells you the car is going at what speed. So everything, every details you can get it. You need not be there, but those details you can definitely get it. What is possible? Is it possible? Because of the Internet of Things. It's a new revolution in the capabilities of the endpoints that are connected to the internet and is being driven by advancement in capabilities in sensor networks, mobile devices, wireless communications, networking, and cloud technology. So IoT plays a very important role in sensor networks. IoT plays a very important role in mobile devices, wireless communication, networking. Nowadays, we are all working in the cloud technology. So, the cloud technology also Internet of Things play a very important role. So by now, we might have crossed more than 70 billion or 100 billion devices which are connected to Internet of Things. And the demand is growing in that way. So demand is growing every now and then, every day, every now and then. So think of any application there is a use of IoT. So probably a day may come wherein everything could be managed by IoT. So there was a saying in Western country, the refrigerator is having an IoT enabled refrigerator wherein the eggs automatically gets filled up as you take the egg for your daily use, as you take the milk for your daily use. If the milk quantity comes down, automatically IoT senses that and it sends a signal to the supplier. Supplier will come and fill the fridge with the milk from your bank account. Automatically money is getting deducted to the supplier's account. All these are done using IoT devices. So the major industry players are excited by the prospects of new markets for their products. Yes, definitely. The IoT products include hardware, software, communication, network protocols. You require endpoints, hubs, control centers of the IoT universe. So these are all the requirements. You need a hardware, as I was meaning. Interface must and should have a hardware. Of course, you need to write a software for those hardwares. For example, you can develop a interface by using Arduino board, and you can program it by using some Python programs to manage your physical device. Totally to call it a IoT. So all these are the different parts of the Internet of Things. So how are you thinking the concept of IoT, right? How are you moving from data to the knowledge? See, imagine I'll take an example of a door lock. Door lock is a physical device. It by itself cannot do anything. You need to develop an interface. You develop an interface using Arduino board, which could mechanically do some activity so that the door lock is locked and door lock is unlocked. So if you design in this way, from that particular device using internet or using network, you will get the data. It's a raw data, which is unprocessed data. What you get it from the door lock or any IoT devices. Now this data need to be converted into information, a meaningful information. How do you convert the data into a meaningful information? So we convert the data into a meaningful information by data filtering, processing, categorizing, condensing, and contextualizing. So these are all the various activities involved in converting your data into an information. That's the second stage. Once you convert that into an information, activity has to happen. That is knowledge. Suppose if you feel that, yeah, information, data is converted into information and you have filtered and you got to know that the door is open, lock is open. So that's a knowledge, so that you can make use of the knowledge and you can take a decision So to lock it, if you find that the door is unlocked, the car's door is unlocked, you can lock it remotely. How? The IoT device connected to the door is sending a raw data. Your program written on a hardware is converting that into information. Your application is converting that into knowledge. And due to this knowledge, you can take some action. So these are the three stages wherein you are inferring knowledge from data, from the raw information into a structured information, and you can put them into an action. Once you get a knowledge, you can put that into an action. So that is the third three basic ideas of the Internet of Things. So scope, where do you find the Internet of Things? We can connect the things to Internet by means of some devices, appliances, machines. We can communicate with the different devices using Internet, which could exchange the data, which could control the information. As I was meaning, I can control my car remotely. So that could include data associated with the users. So all these things are through data. See, I'm getting the information that my car is moving in this direction. It is going somewhere in this place, in this particular speed. Door is not locked. If it is not locked, all these things I am getting it because of the data which I am getting it from the devices which are connected to IoT. So the data get converted into information. Then the useful application is associated with the information that will generate and useful application for the users. So useful application is given to the users which will take all these activities so that some required remote action can be done, can be taken with the help of the IoT. So I've just mentioned you the concept of scope of IoT. Let's look at the different examples. We have a series of raw sensor measurements by a weather monitoring station. See, I was meaning in the previous case raw data. See, if I look at here, see 72,45 is to 84,56. These are the raw data. See, I cannot understand. Any application cannot understand that because these are the raw data. Now, these raw data should be filtered, pre-processed, changed into a such way that it is a combination of temperature and humidity. So, temperature part can be categorized separately, or humidity part can be categorized separately. That is information. Converting, you can convert this data into its proper information by means of pre-processing it. So now the second activity is something which may lead to some information, may lead to some understanding, but still I'm not very sure that I'm able to understand. But definitely this is raw data which I'm not at all able to understand. So this raw data will be converted into an information. So information is little bit understandable, but later this information will be converted into knowledge so that you can take a decision. For example, if you try it, if you get a humidity, let us say 72,45 temperature, 84,56 humidity. Okay, I can say that if the humidity is less than 56 or it is say more than 80, do something. That is knowledge. So if the humidity is less than 56, okay, you switch on the irrigation system so that irrigation system can start irrigating or giving water to the farm which is actually required because the humidity level has come down. So this organized information becomes a knowledge so that application program can work on this information. The information is extracted from the raw data. So these are the three different concepts which are associated with the Internet of Things, wherein a raw data is converted into information. Using information, you can take some decision, and the decision becomes a knowledge. Thank you.